Beneath the surface of our oceans lies a world we were never meant to see. A realm where light dies and life turns into something else. Tonight we're descending, past the bright skin of the sea, into depths where even shape becomes optional. And in that darkness, one creature keeps rewriting its rules: jellyfish. Near the surface they drift like umbrellas. Deeper down, they become glass ghosts, living traps, flashing warnings, silent hunters. So why do jellyfish get creepier the deeper you go? We like to think we've mapped the unknown. We've sent rovers to Mars and cameras beyond the edge of our solar system. But the deep ocean, we've explored only a sliver of it. Down there, pressure crushes metal, signals fade, and soft-bodied animals vanish the moment they reach the surface. Jellyfish make this even harder. They are mostly water, so they leave almost no fossils, and they often dissolve in nets. What we know comes from brief, remotely operated vehicle lights, scattered sightings, and fragments of gelatinous tissue. And yet the pattern is clear. The deeper we look, the weirder they become. Somewhere below, evolution is still running experiments in total darkness today. At the surface, the ocean feels like our world. Sunlight floods the water and fuels plankton blooms, the producers that power the food chain. Small fish arrive to graze, larger fish arrive to hunt them. Even jellyfish fit this logic. They gather where currents concentrate food, drifting through blue water like living nets. You have seen the familiar forms: bells, trailing tentacles, the sting that keeps predators respectful. Some species form huge seasonal blooms, turning bays into slow-moving carpets of gelatin. Here, visibility shapes everything. Color matters. Shadows matter. Predators can spot you, and prey can flee. Most surface jellyfish do not need tricks. They can simply be present where plankton and small fish are abundant. But this is only the ocean's skin. Then the sun thins, and the ocean whispers back. Below a few hundred meters, the light that makes this system possible begins to fail, and jellyfish begin to change with it. In that fading boundary, the rules of survival flip, for good. But sink deeper than the reach of easy sunlight, and the ocean loses its familiar face. Colors drain away, shapes soften. The water turns cold and quiet. We are entering the Twilight Zone, where jellyfish stop looking natural. In the Twilight Zone, the sun's rays are too weak for photosynthesis. The forests of plankton vanish. No plants, no green energy, only the slow snowfall of particles drifting from above, waste, dead skin, broken plankton, tiny crumbs of life. Scientists call it marine snow. To us it looks insignificant. Down here it is everything. And jellyfish are built for this world. They don't chase like sharks. They wait. They drift. They turn empty water into a hunting ground, stretching tentacles like tripwires through the dark. As the light fades, the first creepy shift is simple. Jellyfish begin to vanish. Many twilight species become transparent, their bells like glass and their tentacles like threads. In blue gloom, a predator cannot strike what it cannot see. Even their organs reduce to faint shadows, as if the animal is erasing itself from the ocean. Why does transparency appear so often here? Scientists still debate it. It may be camouflage, a way to disappear in the last traces of light. Or it may save energy. In a world where food is scarce, pigment is expensive. Every molecule spent on color is a molecule not spent on growth, repair, or reproduction. The Twilight Zone rewards bodies that cost less to run. Others choose the opposite strategy, not invisibility, but light. In the twilight, many jellyfish create their own glow through bioluminescence, a chemical reaction that turns bodies into living lanterns. To us it is beautiful, soft pulses, drifting sparks, glowing rings that expand and fade. But down here, light is not decoration. Light is survival. Some jellyfish use it to lure prey, flashing faint signals that draw curious fish closer until tentacles close like a net. Others use it as a warning, an electric blue message that says, "Do not bite this." Some use it to confuse predators, releasing glowing mucus or flashing in patterns that scramble a hunter's aim, and some may use it to communicate, finding mates in a world where even distance is hard to measure. In the Twilight Zone, darkness is not empty. It is crowded with watchers. Bioluminescence is how jellyfish speak to them, and sometimes how they lie. Then the Twilight Zone reveals its greatest spectacle. Each night, as darkness falls far above, billions of animals rise from the deep. Lanternfish, shrimp, squid, an entire moving layer climbing toward the surface to feed under cover of night. At dawn, they sink again, vanishing back into the blue. For a few hours, the ocean fills with travelers from darkness, bringing the deep's rules into shallow water. For jellyfish, this migration is a conveyor of prey. They drift along its edges, tentacles extended, waiting for the tide of bodies to pass through. It is the largest synchronized migration on Earth, greater in numbers than all herds and flocks combined. And yet, it was invisible to us until World War II. Naval sonar operators detected a mysterious false seabed that rose at night and fell in the morning. It was not the ocean floor, it was life. It was a living ceiling, and jellyfish hunted beneath it. The Twilight Zone is where the familiar rules begin to bend, where transparency is armor, where light becomes a weapon, and where shadows hunt. Past 1 kilometer, the last trace of sunlight disappears. There is no dawn, only permanent night. The water chills toward freezing. Pressure multiplies, and jellyfish become something stranger, not drifters, but systems of traps. To a human mind, the midnight zone feels impossible. Nothing should move here, nothing should hunt here. And yet, this is where evolution gets most inventive. In total darkness, vision is unreliable, speed is expensive, and food can be rare for weeks at a time. So jellyfish adapt the only way they can, by turning their bodies into strategy. They grow long, delicate structures that sense touch and vibration. They wait longer. They waste less. They do not chase prey. They turn the ocean itself into the trap. In the deep, a jellyfish is not just an animal, it is a mechanism. Some extend tentacles so long and fine, they function like tripwires in a room you cannot see. Others trail sticky filaments that drift behind them, gathering contact like a spider web drifting through water. Some carry batteries of stinging cells packed with toxins. Microscopic harpoons fire on touch, paralyzing prey before it can even understand what hit it. And because these jellies are mostly water, they can scale their traps without paying the same weight cost a fish would. A larger bell does not need heavy muscle. A longer reach does not need bones. It just needs time, patience, and a current that does the moving for you. In the midnight zone, the creepiest part is not what jellyfish look like, it is what they do. They do not fight the darkness. They use it. They let prey drift into invisible wires. They turn emptiness into contact, and contact into capture. In endless night, invisible means something different. It is not about blending into light. It is about refusing to reflect anything at all. Some deep jellyfish appear as faint outlines, almost nothing against black water. Others carry pigments that make them look dark or blood red. Down here, red light does not travel, so red becomes black. A creature can be brightly colored in theory and still vanish in practice. And then come the games of deception. A jelly may flash once to startle a predator, then go dark and drift away, while the hunter strikes at empty space. Another may glow in moving patterns that pull attention to the wrong part of its body, hiding the delicate core where a bite would kill it. Some release clouds of glowing material, like a smoke screen made of light. In this zone, bioluminescence is not just a flashlight. It is misdirection. It is camouflage by confusion. It is a lie told in photons. Jellyfish also break one of our most basic assumptions, that an animal has one life. Many species live twice. First as a tiny polyp fixed to rock, cloning itself in silence. Then, when conditions are right, it transforms, releasing medusae into open water like a sudden outbreak of ghosts. It is an existence split between stillness and drift, between hiding and hunting. And when jellyfish die, they do not simply disappear. In mass events, they can sink in jelly falls, a soft blizzard of bodies dropping into the deep. For scavengers, it is a rare pulse of food. For the midnight ecosystem, it is an oasis made of gelatin. 4 kilometers down, we leave the open water and reach the abyssal plain, a desert of mud stretching for thousands of kilometers. No reefs, no landmarks, just cold, pressure, and scarcity. And yet, even here the abyss produces giants, just not the kind we expect. In the deep sea, some gelatinous animals reach absurd scales. Enormous bells and tentacles that extend like fishing lines into darkness. Stranger still are colonies that behave like single creatures, long ribbon-like jellies made of many individuals working as one. They are not fast, they are not muscular, they are simply large, built to intercept whatever the abyss can afford to deliver. This feels uncanny because it is so quiet. There is no roar, no teeth, just a vast shape drifting in black water, waiting. Why does size appear in a place with so little food? Some suggest efficiency. A large body can drift longer, store more energy, and reduce the risk of being eaten. Others think size boosts the odds of contact in an empty ocean, more surface area, and more chances to catch something. The truth is, we still do not know. In the abyss, most meals arrive as accidents. A dead fish, a sinking squid, a rare pulse of organic matter falling from above. When it happens, scavengers gather fast, stripping the gift down to bone and dust. These jackpots don't just feed the bottom, they ripple upward through the whole food web, creating brief seasons of abundance in a world defined by famine. Not every gelatinous creature here is an active hunter. Some survive by collecting what the water provides: particles, detritus, the drifting leftovers of life above. It's slow, efficient, and perfectly suited to scarcity. And beneath it all is the hidden engine: microbes. Every grain of sediment is loaded with microscopic recyclers, breaking down carbon, nitrogen, and sulfur, keeping the deep ocean's chemistry alive, quietly. Beyond the abyssal plain lies an even deeper frontier: the trenches. Scars carved by tectonic forces pull the seafloor down into darkness. This is the Hadal Zone. Here the ocean becomes an underworld. The Hadal Zone starts around 6,000 meters and drops toward the deepest points on Earth. If Mount Everest were lowered into a trench, its summit would still be underwater. Pressure here would crush a human instantly. And yet, life survives. Even in trenches, gelatinous animals appear, soft bodies drifting through black water, looking too fragile for such force. Even here, traces of us arrive, carried down from the surface. Along trench walls, hydrothermal vents power a different world. Microbes feed on chemicals from the crust, and entire food webs rise without sunlight. That discovery sparks a larger question. If chemistry can fuel life here, why not beneath the ice of Europa or Enceladus? The deep ocean is still a world of questions. Down there, the simplest drift can become a hunt. Every remotely operated vehicle dive reveals jellyfish that look invented, transparent bells, red shadows, drifting chains of living colonies. We still don't know why some become enormous while others nearly disappear. We don't know why bioluminescence is so common, or why its signals vary from lures to alarms to camouflage. And we don't know how many species we've never seen because they dissolve before we can study them. Maybe that is the point. The sea still holds secrets, secrets worth protecting and secrets worth discovering.